This is a rule. Why anybody ever came up with it, I don't know. I'm not the one that decided it, but you never leave and I'm going to say radical because that can be square root, cube root, whatever, in a denominator. Now we say dividing, but we're going to be doing them as, like 12 over 3. We'll be doing them like that, as look like fraction division in a denominator. I think it'll come back to you from, and I'll put an exclamation point there, from what we did in geometry. These are very much, the left page is definitely the geometry side of it. So you are going to want to first to simplify / reduce, which you would probably call canceling, as much as you can. I'll show you something else. I think you will remember it, but you don't want to use it until it's a last resort on this type of problem. What we're doing here is what's called a monomial, and I didn't tell them that till I got to page 57, over a monomial. That means there's no adding or subtracting on the top or bottom. It's just a fraction, like this, number 1. Let's do 6 square root of 2 over 2 square root of 8. Now, I can't leave that square root of 8 on the bottom. Now, what I'm calling simplifying is you could break that 8 down. Factor tree, 2 times 2 times 2, and then do that. If you can avoid factor trees, it'll save you a little bit of time. The reducing or canceling, and we said it in Algebra 1, you can, and in geometry, you can cancel the inside, you can cancel the outside. Or, as we say more in Algebra 2, you can cancel rational, or you can cancel irrational, or both. In this case, I can cancel the rational. I can divide by 2. I kind of need glasses, but I don't really need glasses. And then over here, I can do, and now be careful because these are under the square root, under the radical. The 2 goes into 2 one time, and 2 goes into 8 4 times. So on this one, especially in your notes, put 3 square root of 1, and you have 1 square root of 4 left. Now, if you get good at it, you probably can skip that step, but I want you to see what's left. So you're left outside, you're left inside. Now, can we clean that up? Do we know the square root of 1? So 3 times 1 on top. Do we know the square root of 4? 2. So we got 1 times 2, so we get 3 over 2. Now, in that case, we didn't end up with a square root on the top or bottom, but you cannot have a radical on the bottom. I tend to not do the simplifying because it just takes more time. If I've got to break down the square root of 50, or if I can cancel with it, it makes it a little bit easier. That's kind of like this one. I've got the square root of 28 over the square root of 4. Now see, if you look at it as simplifying, you could go ahead and break the 28. It's going to become 2 square root of 7, and you can write the square root of 4 as 2, but I'm going to treat it as the inside-outside. Now there's understood ones out front, just like ones in front of x's, but I can cancel my 4 and my 28. 4 goes into 28 7 times. But now recognize that that square root of 7, it's still under the square root, and that's square root of 1. The square root of 1 I know is 1, and I'm putting all the steps in. That just makes it a little bit easier for you. We have a square root on top. We don't have one on the bottom, and that's what you want to do. If you can, you want to do all of this first before you have to take that second resort. Let's do one more. Let's do 3 square root of 20, 3 square root of 2 over, I marked my stuff out, then I can't read my writing, 6 square root of 32. Now, I can't break the square root of 2 down on top. It's irrational, and that's it. But I can break the square root of 32 down if you want to. But I like the idea of reducing the rational part on the outside and the irrational part on the inside, because 2 goes in 32 16, and that makes my life a lot easier. I get 1 square root of 1 on top, and I get 2 square root of 16 on the bottom. So 1 times the square root of 1 is just 1. But now what's the bottom going to be? So you got 2 times 4 on the bottom, which is 1 over, and I'll even put 1 times 1 on top if you need it. over 8. But then you get to problems like this. Let's do 8 over the square root of 5. And I'm going to start a star here because this is where the split happens. You can't cancel, even if that was a square root of 6 or a square root of 8, I could not cancel these because that's rational. There's a 1 on the outside. There's not a radical, not an irrational part here. I can't do anything. I've got to get rid of that square root of 5. So what we found, and I had it up here on the board, and let me put it on paper for the notes. If you remember from elementary school, you know, the teacher would take a pizza and they would cut it in half and give you half of it. They would cut it in 6, do a very good job of that, and give you 3 pieces, or 8 and give you 4 pieces, and you were getting the same, you might be getting more pieces, but you were getting the same amount of pizza. 1/2, 3/6, 4/8, 5/10, it's all 1/2. Well, how that happens is because when you multiply a fraction, I'll do the 3/6, times 1, you get that fraction. And that's true for any number. 8 times 1 is 8, 12 times 1. But what if I make that 1 something like 2 over 2? If I take 1/2 and multiply it, say, by 5 over 5, and I get 5/10. Well, I know those are equal because I've seen teachers do this. They'll put a 1 over that 5 over 5, and so 1/2 and 3 5/10 have to be equal because you're multiplying by 1. Well, that's what we're going to do. We're going to do what's called rationalize the denominator. You may remember this from last year. Rationalize just means you're going to make it a rational number. You're going to get rid of that irrational number right there. And we're going to multiply by the radical. I'm going to do it generically radical because this works for any of them. And I'm going to put in the denominator because we're only trying to get rid of that square root of 5. Doesn't matter if you have a square root on top. In the denominator, in the form, we could put that in with commas too, in the form of 1. So you find what you need to get rid of, and you multiply it as square root of 5 over square root of 5, which is 1. Now, let's multiply fractions. On top, you have 8. That's rational. This is irrational. You've got a 1 in front of those. So you've got 8 square root of 5. And on this one, you have the square root of 25. See? 1 on the outside and 5 times 5 on the inside. 8 square root of 5, I can't do anything to. But what about this 1 times the square root of 25? What's the square root of 25? It's equal to 5, so you got 1 times 5, which is 5. Now, that's your answer. We cannot cancel these because one is, as we said in geometry, one's inside, one's outside. One is irrational, one is rational. We rationalized the denominator. We took this irrational number and made it rational. Let's do one more like that, and then we'll add the algebra 2, and I'll do that. But it's like the ones we did at the top. Okay, so we've got 12 square root of 5 over 15 square root of 10. Now, your first instinct now tends to be to want to do this. Are you looking? But I'm only going to do this as a last resort. Can I do anything like we did 1 through 3? Because you really don't know. Are you going to have to do it? So on these, I can divide 12 and 15 by 3. Gives me a 4 and a 5. And the 5 and 10 will reduce to 1/2. So I get 4 square root of 1 over 5 square root of 2. And you can just write that 4 square root of 1 as 4 over 5 square root of 2. Now, that made it so much easier, even though at this point I can't do anything. The 4 and 5 won't cancel. I don't have anything to cancel with the 2. This one's outside, this one's inside. Now, we're going to rationalize. Now look, we're only going to multiply by the radical part in the form of 1. That's the only thing we got to get rid of. We cannot have a radical in the denominator, a square root in the denominator. So I'm going to multiply by square root of 2 over square root of 2. If you want to put 1s in front of those, you can. You get 4 square root of 2 on top. You get 5 square root of 4 on the bottom. The top is 4 square root of 2. What's the bottom going to be? What's this? What's the square root of 4? 2. So you got 5 times 2 on the bottom, which is 4 square root of 2 over 10. Oop, said it right, wrote it wrong. Now look at your outside. So 2 goes into 4 2 times, 2 goes into 10 5 times. See, this one's inside. We didn't have it inside to cancel. So I've got 2 square root of 2 over 5 is what we call a binomial over a monomial. Okay, you will have to rationalize. Must rationalize. And I was going to put no canceling, but that comes back to what you did on quiz today, so we'll kind of address that. Number 6. We'll start out with one like, I don't really like the one I did for them, so I'm going to do 2 plus the square root of 5 over the square root of 6. Now, even if this was a 6, and that's 6, even if this was a square root of 6 and square root of 6, you can't cancel addition. Remember your quiz today? You had to make it multiplication. You can only cancel multiplication. That ties in with that. But we're going to do something that Ms. Newberry does in college algebra that actually is going to come up with us later, which will make it a little bit easier. We're going to actually make, well, I'll show you when I get to it in just a minute. When you've got a radical on the bottom, your only option is to multiply by that square root of 6 over square root of 6 is what you're going to have to do. Now, in lesson 23, we did multiply. See right here, you had one where you had something outside and you had to distribute it to 2. Well, that's what we're going to do. We're going to have to distribute this square root of 6 to both of these. So I've got 2 square root of 6 plus the square root of 30. Now look careful. See, the 2 in outside, 6 inside. 2 square root of 6. Look at these two. Outside are 1s, inside are 30s, and then underneath you're going to get the square root of 36. So I get 2 square root of 6, and very rarely will these break down except the bottom plus the square root of 30 over 6. Now a lot of people are tempted to start canceling there, but it's still not multiplication. And here's another way you can reduce fractions. Do you remember in elementary school, you might have like, or late middle school, early middle school, you might have like 2 6 plus 1 6. 2 plus 1 over 6. That's how I want to say it. So if I have a fraction like, maybe I have here, like 2 square root of 6 plus square root of 30 over 6. So if I have like 8 plus 3 over 10, that's the same thing as 8 over 10 plus 3 over 10. We're actually putting it back where you're used to usually putting the tops together and leaving the common denominator. We're actually separating it back into 2 fractions. And this is the way most people do it in your upper math classes. So at this point, we're going to write 2 fractions. We're going to write 2 square root of 6 over 6 plus the square root of 30 over 6. And this is a perfect one. Because will this one reduce? What cancels here? The 2 and the 6. If you'll separate them, now do you see why these won't? This one's inside is irrational, this one's rational. So I have square root of 30 over 6. You can leave it as this. Sometimes they do. This is the best because that's what is where most people miss it. They start trying to cancel here. So if you'll separate it into 2 fractions, it makes it much easier.